Of course, we can't always solve systems with the graphing method. That's going to be cumbersome, and the intersecting point may not always be a really nice whole number intersection. So we're going to learn several methods, and the first one we're going to learn is called the substitution method. So to do that, we're going to have our two equations because we have a system. We're going to solve one of those equations for one of the variables. So we can either solve it for x or we can solve for y. It doesn't matter which one we solve for to begin. Then we're going to substitute for that variable in the other equation. Then you're going to ask the question, can I solve that equation that I come up with for the remaining variable? And if the answer is yes, it can be solved, then we're going to solve it and substitute into either equation to find the value of the other variable. If it can't be solved, then that means that it's going to result in something that's never true, which means there's no solution, or something that's always true, which means that there's going to be an infinite number of solutions. So example 1, solve each system by substitution and write your solution as an ordered pair. So I'm going to consider my two equations here, and I'm going to solve one of them for one of the variables. Well, you can see, if you're very observant, that y, this equation is already solved for y. It says that y is equal to 2x minus 1. So this is what it means to solve one of the equations for one of the variables. This is solved for y. So I'm going to write down just the y equals 2x minus 1 to the left. Now what I'm going to do is I am going to take this 2x minus 1 and I'm going to substitute into the other equation for the y. So this is going to say 7x minus 2. Now in place of the y, I'm going to put 2x minus 1 because here it says y is equal to that. And then it's equal to 11. So just take this and instead of the y, put in 2x minus 1. Now I'm going to solve this now for the x. So I'm going to distribute 7x minus 4x plus 2 is equal to 11. Combine terms, so I get 3x plus 2 is 11. I'm going to subtract the 2 from both sides, so I get 3x is equal to 9. And then I'm going to divide both sides by 3 and get that x is equal to 3. So I have part of my solution, and I know what the x value is. Now what I'm going to do now is I'm going to take this and I'm going to take this value of x, I'm going to place it into the other equation. So now this is going to say y is equal to 2, and in place of the x I'm going to put 3 and minus 1. So I get y is equal to 6 minus 1, y is equal to 5. So there's the other part of my solution. Now I need to write this as an ordered pair because that's what it asked for, ordered pair. So x first, so 3 comma 5 would be my solution. Now the nice thing about systems is that you can check your answers. So I'm going to check my answers. I'm going to put a 3 in for the x, so I get 7 times 3. And then for the y, I'm going to put a 5 in. 2 times 5 is equal to 11. 21 minus 10 is 11, and I can see that that checks. Then check it into the other one. So this time it starts with y. So make sure I put the 5 in for the y is equal to 2, and then x is 3. So 2 times 3 minus 1. So 5 is equal to 6 minus 1. So I can see that that checks, and that is the solution. When I take a look at example B, I can see that they're both solved for y. So I can take one and put it into the other. So I'm going to take this 1/3 x minus 5 and place it in for this y. So that now this is going to say 1/3 x minus 5 is equal to the right side of this, which is 1/6 x minus 3. And I need to solve it. And so I've got fractions, and of course I want to eliminate my fractions and multiply 3 by the common denominator, which is 6. So that's going to give me 2x minus 30 is equal to x minus 18. Then I'll need to subtract my x on this side, so subtract, that gives me x, and then add my 30 on this side, so negative 18 plus 30 is 12. So I get 12 for that answer. Now I'm going to take this and I'm going to put it back into either one of these. It doesn't matter which one. So let's put it into the second one. So I will then have y is equal to 1/6. Now I'm going to put in the, for x, I'm going to put in that 12. And so 1/6x, then minus 3. So y is equal to 1/6 of 12, which is 2, minus 3. So y is equal to negative 1. So my solution then is going to be 12, comma, negative 1. Get your x in first. All right, so now let's check it. So when we check, we're going to have y, which is negative 1, is equal to 1/3 times 12 minus 5. So negative 1 is equal to 4 minus 5, and I see that checks. And then plug into the second one, so negative 1 is equal to 1/6 times 12 minus 3. So negative 1 is equal to 2 minus 3, and I see that that checks. You check it in both of them because sometimes it will check in one, but not the other.